All right, in section 1.2, we're looking at linear equations. So some mathematical words that you need to be able to understand and communicate correctly, especially the difference between an equation and an expression. So an equation is a statement that two algebraic expressions are equal. So in an equation, you will definitely see an equal sign, and you solve for the values that make the equation true. So solve would be the directions that go with that. An expression, on the other hand, does not contain an equal sign, and you may be asked to just simplify or to evaluate it. A linear equation, so think of a line in one variable, would be an equation that can be written in the form ax plus b equals 0. And a linear equation has exactly one or sometimes no solution. For example, x equals x plus 1 has no solution. And if you think about why not, and most of us would go about that algebraically, if you think about subtracting x from both sides, you would end up with 0 equals 1, and that would be a false or a not true statement. Okay, so that would be no real solutions. All right, let's practice these. All right, so on this first one, where should you start? Okay, and again, I'm modeling exactly what your work should look like. So keep that in mind if you're still trying to figure out what homework should look like. Okay, all right, so distributing the 5 to the 2x minus 3, we would have 10x minus 15, distributing the negative 1 to the x and the 7, negative x minus 7 equals 4x minus 3. We should be combining like terms on the left. So 10x minus x will give us 9x. Negative 15 and negative 7 would be negative 22 equals 4x minus 3. Go ahead and finish solving for yourself while I also do it silently. Remember, we like improper fractions in upper level math, so that's the only form that you should give me. It does need to be fully reduced. Check that that 19 over 5 does not reduce. Keep that nice horizontal fraction bar for when we have more complex fractions, and box your answer, and you are set. All right, next one. Again, if we're distributing the 6x minus 18 minus 3x, distributing the 3x minus 18. And if we go ahead and combine like terms, 3x minus 18 equals 3x minus 18. Okay, some of you might be thinking what your answer is probably there. Please don't stop at that point. Okay, you either need to come up with a true or false statement with just numbers, not variables. I think it makes it easier. So if you take away 3x on both sides, you're left with just negative 18 equals negative 18. Remember, if you get a false statement, like we've said, it's no real solutions. But if you get a true statement, such as this, then you're telling me x can equal all real numbers. And that symbol, again, is just kind of a double line and this fancy looking R. Okay, or if we were doing interval notation, you would be telling me x equals negative infinity, comma, infinity. Okay, both with parentheses. All right, fractional equations. So to solve fractional equations, find the least common denominator and multiply every term by this least common denominator. Okay, so definitely, it's like clearing the fractions that we were doing with those other baby fractions. Definitely want to turn all 4 terms that I see in this problem into fractions. Remember, terms are split by plus and minus signs. So put that over 1. Now I've got 4 terms. Common denominator between 3, 2, 1, and 9 is 18. So you either can write 18 over 1 in front of each one of these, I like to just write it once, but I got to think about cross-reducing while I'm doing it. Okay, so when I'm distributing to this first one, I'm thinking 3 goes into 18 from the denominator into the 18 in the numerator 6 times, and then 6 times x is 6x. Okay, to the next one, I'm thinking 2 goes into 18 9 times, and 9 times negative x would be negative 9x. 18 times negative 3 is negative 54. And don't forget the right side, 9 into 18 goes twice, and 2 times the 1 is the 2. In this very first step right here, if you don't have the fractions gone, then you did something wrong. That was the whole purpose, was to clear the fractions. Okay, so finish that one up for yourself. Again, I'm going to suggest improper fractions fully reduced, and suggest that you put the negative sign in the top so that there are no issues. Okay. All right, next, rational equations. So equations involving a variable in the denominator. Here's the big thing. You must. We'll talk about this the entire year. You must check the solutions you get from any rational equation, as they may be extraneous. So extraneous roots are solutions that do not satisfy the original equation. Okay, extraneous solutions often occur when you multiply through by a variable. For rational equations, you need to throw out any solutions that cause a 0 in the denominator of the original equation. Okay, can't divide by 0, which you guys know. All right, so here we go. On this one, definitely, like we've been talking about, you want to always factor everywhere first. Okay, so on this one, I've got 2 over. How does that denominator factor? X minus 4, x minus 2 equals 1 over x minus 4. And like we've talked about, make all your factors look the same. So I don't like that last one that the x is in the back. So I'm going to fix it. Okay. I'm going to take the negative that's lined up with this. I'm going to factor out a negative in the denominator and leave myself with x minus 2. Okay. And then at this point, I'm really going to see what my common denominator would be. Okay. I'm also going to say, we'll figure out what to do with that negative for a moment. Okay. But here we go. Your common denominator, just like it was with the numbers, got to have all the factors included. Your common denominator that you should be using is x minus 4 and x minus 2. So you're multiplying by that over 1, right? We can distribute it because it's an equation. It doesn't change the problem because you're distributing it to both sides. Okay. When you distribute to the left side, both factors in the denominator cancel with the ones in the numerator. Okay, when you're going there to there. And so you're really just left with the 2 equals. When you go here to here, the x minus 4's cancel, so you're left with the 1 times the x minus 2. Okay. And lastly, I'm going to say plus, and the plus is because of the minus minus. Okay. The x minus 2 is going to cancel. I'll be left with the 2 and the x minus 4. All right. Again, let me see if I can highlight for you. Okay. So really the minus minus right there is what's turning into that plus. Okay. So that's all I did. That's all I did. Nothing too fancy there. All right, go ahead and finish solving that one for yourself. Okay, now for rational equations, remember to always check this. If you've got variables in the denominator, you've got to check those answers. So I'm not boxing that on purpose, okay? I'm hesitating on the box and I'm going back and checking. But if I plug x equals 4 in to a couple of places, here or here, I would have an issue. I'd have a 0 in the denominator. Okay, so this is exactly the same work that I would see like for homework or for a quiz from you. And you're going to be telling me that the answer is actually no solution, but I have to be able to see that you did the algebra right to this point. Okay, so I would just see you, since you've got a pencil, you don't have the colors to help with, but in the pencil, I would just see you lightly cross out like x equals 4, and your final answer would be no solution. This is the only way the no solution symbol looks. If you don't know that or you can't remember it, write the words no solution, okay, or no real solution. There you go. All right, all set. So equations with one fraction on each side, also known as a proportion, can be solved by, you know the name for it. What is it? It is called cross multiplying. Cross multiplying. Okay, which is the same as multiplying by the least common denominator. Okay, and we'll show you that. So if I took this, right, if I took this, like the last problem, and maybe cleaned it up to have a little more notation so that we're not messing up some things, okay? Now, if you think about cross multiplying, I'm going to say it doesn't matter which way you go. I would end up with 2 times the quantity of x plus 1 equals 3 times the quantity of x minus 3. Now let's go back for a minute and prove to you that it works just like the last one did. If I had just said, all right, let's just put brackets around this and multiply by the common denominator, isn't the least common denominator x minus 3 times x plus 1 all over 1? Think about distributing that. If you distribute there, right, you end up with the x minus 3's canceling, you get the 2 and the x plus 1. Same thing we did below. Okay, and that one, the x plus 1's cancel, you get the 3 times the x minus 3. Okay, so that's why it's called cross multiplying. It's the same as, we'll go ahead and write that here, same as multiplying by the least common denominator. Okay, all right, go ahead and finish that for you and decide for yourself what your final answer would be. Now I'm going to hesitate at least at that point. Hopefully you got x equals 11. I'm hesitating before I box it. If I plug 11 in, it doesn't cause any issues in the denominator. If we do ask you to show the check step, guys, because we said you got to check those answers sometimes when you're multiplying through by a variable. So your check step would look like this. So I should just see from you plugging 11 back into the complete original equation with no simplification. So you would have 2 over 11 minus 3, so 8 equals 3 over 11 plus 1, so 12. Can't stop there. Show me if it's true or not. If you reduce, you would get 1/4 equals 1/4. And if I just see you putting that check mark, I'll know you've checked it. And now that means since that's a true statement, you can go ahead and box x equals 11. That is a true solution. Okay. All right, literal equations. So equations involving more than one variable where you solve for one variable in terms of the other. So literally, I could ask you to solve for a or m or x. Notice these are asking you to solve for x. Okay. So if I'm asking you to solve for x, then of course, just like always, isolate the x term by itself. So I'm going to go ahead and, sorry about that, move the 2m to this side. So a minus 2m equals 2x. And if I want x by itself, I need to divide both sides by 2. Okay, so I'd like it to be 1 fraction. That's actually where I prefer for you to stop. All right. Number 7, if I'm going to isolate x, well, then I need to get the 2 terms with x on one side and everything else to the other, just like always. So I'll subtract the mx. I'll make it a squared minus m squared. And then if you're solving for x and it's in multiple terms, right, what do? GCF, factor it out. So if you take out that x, you're left with a minus m equals a squared minus m squared. And you've got x times something. If you want to get rid of multiplication, you divide. So you're going to divide both sides by a minus m. At the same time, I'm going to go ahead and factor that guy, because you should recognize that as difference of perfect squares. So a plus m times quantity a minus m divided by the a minus m, right? And then since you have an entire factor, those cancel with each other, the whole a minus m. So x equals a plus m. And last one. Okay. Again, we're trying to solve for x. So we need to do a little distributing and stuff here. So 4x plus 12 minus 5a equals 3a squared plus 3ax. All right, so if I'm solving for x, then go ahead and put all the terms with x on the same side. So I'll keep the 4x here. I'll move the 3ax to this side. Right side, I'm going to put it in order I'm used to. 3a squared, put the 5a next, and it would be negative 12 now, so that you've got a constant. If I'm solving for x, you're going to factor that out, leaving you with 4 minus 3a equals the 3a squared plus 5a minus 12. And if I want x alone, I'm going to have to divide by the 4 minus 3a. However, at the same time, well, let's do some factoring and some simplifying. So here we go. This one's going to factor into, I know it'll be 3a times a. So what works? It would be minus 4 and plus 3. All right, those both have a in the front. So while I'm dividing by the 4 minus 3a, I don't want to do too many things at a time, but I want the a in the front. Okay, so I'm going to factor out a negative, leaving me with 3a minus 4. And now the whole quantity cancels. And so I'm left with x equals, I still got that negative in front of quantity a plus 3. I would take it from you either way. You could distribute the negative or not. Okay, as long as you're giving me the correct information.